Hello, George Romanic here. Welcome to Fundamentals of Weather and Climate playlist. In today's video, we are going to talk about direct and diffuse radiation, and we will also define the concept of irradiance. We start with that classical figure that we are examining. Here is the surface of the Earth. This is the top of the atmosphere. And we know that certain radiation reaches the top of the atmosphere from the sun. And that is the solar constant, 1367 watts per square meter. In the previous video, we looked into the concept of light being scattered off the particles in the atmosphere, namely molecules and atoms and dust. So light is being scattered, and let's say this scattered light reaches the surface of the Earth. We know that incoming ray can also pass through the atmosphere without interacting with atoms and molecules and reach the surface of the Earth directly. This is known as direct radiation, whereas this is known as diffuse solar radiation. So if I now make this figure larger, and I say that this over here is 1 meter, and it goes 1 meter into the whiteboard, so the area of this region would be 1 square meter. Then we would say that on this 1 square meter, we can have a light that is directly falling without interacting with any particles in the atmosphere, and on this 1 square meter, we can also have light that interacted once or multiple times with the particles in the atmosphere, and then it falls on this 1 square meter. How do we quantify this? Well, first we introduce a concept known as irradiance. So what is irradiance? Irradiance is given in the units of watts per square meter, so power per square meter. Radiance is the amount of radiant energy, namely electromagnetic radiation that we receive from the sun, that falls on 1 square meter every second. Because watt is joule per second, so that is energy each second per square meter, per square meter on which it falls. So that is irradiance. But clearly now we can define irradiance associated with this direct radiation, and we can define irradiance associated with this diffuse radiation. And that's what we will do now. You see, if I alter this figure a little bit, then we know, why would I alter this figure? Well, we know that our planet is round, so this would be 1/2 of the planet. And horizontal surface here is not the same as horizontal surface here, is not the same as horizontal surface here. So the orientation of the horizontal surfaces is different with respect to the sun that is perhaps here far away. This would be indeed perpendicular to sun, but these are not perpendicular to sun. So what we therefore do when we look into this direct radiation, we introduce another surface, and that is surface that is normal to the incoming ray of direct sun's light. So this normal would be different at different latitudes. And therefore, we can have this angle here, which we call angle alpha, so that the irradiance associated with this direct radiation can be expressed in the following way. Direct normal irradiance would be irradiance on this surface that is perpendicular to the incoming radiation times cosine of this angle alpha. Cosine of this angle alpha is the amount of direct solar radiation that is reaching this horizontal surface at different latitudes. Because as I said, this angle alpha will be different for different latitudes on our planet. But remember, we also have diffuse radiation that can reach this horizontal surface. So I can add here this term, which is known as diffuse horizontal irradiance. So diffuse horizontal irradiance is the amount of this diffuse light that is falling on the horizontal surface. I know what some of you are saying. Why am I not introducing some special surface like this one to measure diffuse light? I'm not doing it because I don't know from which direction diffuse light is coming. I always know that normal direct light is coming directly from the sun. But this one might approach horizontal surface like so, but I might have some other light ray that approaches it like this. So I cannot construct some clever surface. I only can measure it on this horizontal surface. At any rate, these two terms together are known as global horizontal irradiance. So what is global horizontal irradiance? Well, that's total irradiance. It is associated with direct light that we receive from the sun through this term, and it is associated with diffuse light that comes from the sun but undergoes one or multiple scattering processes in the atmosphere. If you want to learn more about scattering, check my previous video. Now I would like to show you a few maps that people created for our planet that show on average the amount of global horizontal and direct normal irradiances. Stay tuned. Here we have a map that shows global horizontal irradiation, and of course different colors provide different values, and they are either daily totals or yearly totals, and the units are kilowatt hour per square meter. Kilowatt hour is unit of energy that is often used in the field of energy sector, such as renewable energy, and these types of maps are used to support decision making when it comes to installation of solar panels. So you can see that tropical regions have much higher global horizontal irradiance than higher latitudes. So that is not difficult to conclude based on the discussion that I just presented conceptually. But here you can see actual values, but keep in mind, these are kilowatt hours. So if you want that in watts or some other unit, watt hours or so on, you have to convert it. This is direct normal irradiance, and we can see the direct normal irradiance have somewhat lower variability than the global horizontal irradiance, and we can also see that the values are much higher. The values, of course, are much higher because, remember, we are looking into a plane that is normal to the incoming solar radiation. So the amount of direct normal irradiance that contributes to the global horizontal irradiance is only the amount that needs to be multiplied by cosine of that angle alpha. Nevertheless, these are values that you can use for your reference, and here you can see where I found those maps. Indeed, they are used a lot in solar energy industry. Until next video, goodbye.